Hello everybody. In this lesson, I want to describe the difference between mass and weight, SI units, and density in a simple and easy way. Let's start. The terms mass and weight are often used interchangeably, although strictly speaking, they are different quantities, whereas mass is a measure of the amount of a matter in an object. Weight, technically speaking, is the force that gravity exerts on an object. For example, consider one person one time on the surface of the earth and the other time on the surface of the moon. The mass of this person is always constant. As you can see, the mass is constant, always 80 kilograms, while its weight is different and depends on the gravity force. On the surface of the moon, gravity is only 1/6 of the surface of the earth. So, of course, the weight is different, as you can see. For many years, scientists recorded measurements in metric units, which are related decimally, that is, by power of 10. Power of 10. In 1960, however, the General Conference of Weights and Measurements, the International Authority of Units, proposed a revised metric system called the International System of Units, abbreviated as SI. The following table here shows the 7 SI base units. All other units of measurement can be derived from these base units. We have 7 base units with such a symbol, and the other measurements can be derived from them. The SI unit of mass is the kilogram. Unlike the units of length and time, which are based on natural processes that can be repeated by scientists anywhere, the kilogram is defined in terms of platinum iridium alloy. Here we have the platinum iridium alloy. What's that? This alloy, it is kept in a vaulted, the International Bureau of Weights and Measures in Severs, France. In 2007, it was discovered that the alloy has mysteriously lost about 50 micrograms. So the weight didn't change. That's why that can be considered as a unit. However, let's come back to my sentence. The kilogram is defined in terms of platinum iridium alloy. In chemistry, however, the smaller gram is more convenience for these units. The SI unit of length is the meter, I told. And the SI derived unit for volume is the cubic meter. Generally, however, chemists work with much smaller volumes, such as cubic centimeter and cubic decimeter. So cubic centimeter and cubic decimeter. Another common unit of volume is the liter. A liter is the volume occupied by 1 cubic decimeter. So 1 liter is equal to 1 cubic decimeter. Density. The equation for density is D equals to M divided by V, where D refers to density, M refers to mass, and V refers to volume, respectively. Because density is an intensive property and doesn't depend on the quantity of mass present, for a given substance, the ratio of mass to volume always remains the same. In another word, while volume increases as mass does, so the density remains constant. Density usually decreases with temperature. Here are the units related to the density, and now let's solve a problem regarding density. A piece of gold ingot with a mass of 301 gram has a volume of 50.6 cubic centimeter. Calculate the density of gold. So it's only easy by writing the equation of density. We substitute the amounts that we have here. We have the mass actually and the volume. So if we want to calculate by dividing mass to volume, we can get 90.3 for density with gram divided by cubic centimeter. There are two practices for you, and I will solve them for the next session. Next session, I will talk about temperature scales like degrees Fahrenheit, degrees Celsius, and Kelvin. So let's follow me.